I'm using Ubuntu 10.04. We assume that you already have an idea about the Linux operating system and have some basic idea about commands. If you're interested, it is available through another spoken tutorial on the following website. Also note that Linux is case sensitive. All the commands used in this tutorial are in lowercase unless otherwise mentioned. Most of the work that we do in Linux is through a terminal. When we have to execute a command, we generally type through the keyboard. Say we have to find the date and time. We simply type through the keyboard date and press enter. So we normally give input through the keyboard. Similarly, we see that the output of our command is also displayed at the terminal window. Also say some error occurs while we are executing some command. For example, we type cat space AAA and press enter. Now, no such file by the name AAA exists, so there is an error displayed saying so. Now this error also comes on the terminal window, hence we see error reporting is also at the terminal. Now inputting, outputting and error reporting are the three special actions related to commands. Before learning about redirection, we should know about two important concepts, that of stream and file descriptor. A Linux shell like bash receives input and sends output as sequences or streams of characters. Each character is independent of the one before it and the one after it. Streams are accessed using file I/O techniques. It does not matter whether or not the actual stream of characters comes from or goes to a file, a keyboard, a window, etc. In Linux, every opened file of a process is associated with an integer number. These numeric values are known as file descriptors. Linux shells use three standard I/O streams. Each of them is associated with a well-known file descriptor. stdin is a standard input stream. It provides input to commands. It has file descriptor 0. stdout is a standard output stream. It displays output from commands. It has file descriptor 1. stderr is a standard error stream. It displays error output from commands. It has file descriptor 2. Input streams provide input to programs. By default, it takes from terminal keystrokes. Output streams print text characters by default to the terminal. The terminal originally was an ASCII typewriter or display terminal, but is now more often a text window on a graphical desktop. We have seen that the three streams are connected to some files by default, but in Linux we can change this default behavior. We can connect these three streams to other files. This process is called redirection. Now let us see how redirection is done in the three streams. First, let us see how the standard input is redirected. We redirect standard in from a file using the left angle bracket operator. Let us see how. We know that the use of wc command is to find the number of lines, words and characters in a file. Type wc on the terminal window. Now press enter. What happens? We have a blinking cursor. It means that we need to enter through the keyboard. Enter some text. Say, this tutorial is very important. Now press enter. Now press Ctrl and D keys together. Now the command will work on the lines that we entered. The command will give an output on the terminal. Now here, no file is given after wc command, so it takes input from standard input stream. Now the standard input stream is by default connected to the keyboard. Hence, wc will take input from the keyboard. Now if we write wc space left angle bracket space test1.txt, what happens is that wc will tell us the number of lines, words and characters in the file test1.txt. Now type wc space test1.txt. We see the same result. So what is the difference? When we write wc space test1.txt, the command opens the file test1.txt and reads from it. But when we write wc space left angle bracket test1.txt, wc still does not get any file to open. Instead, it looks to pick up the input from standard in. Now we have redirected standard in to the file test1.txt. Hence, the command reads from test1. but actually it is unaware as to from where the data is coming to standard in. So we have seen how to redirect standard input. Now let us see how to redirect standard output and standard error. There are two ways to redirect output or error to a file. Suppose n refers to the file descriptor. N single right angle bracket redirects output from file descriptor n to a file. You must have write authority to the file. If the file does not exist, it is created. If it does exist, the existing contents are usually lost without any warning. N double right angle bracket also redirects output from file descriptor n to a file. Again, you must have write authority to the file. If the file does not exist, it is created. If it does exist, the output is appended to the existing file. The n in n single right angle bracket or n double right angle bracket refers to the file descriptor. If it is omitted, then standard output, that is file descriptor 1, is assumed. So, just the right angle bracket is same as one right angle bracket, but to redirect error stream, you have to use two right angle bracket or two double right angle bracket. Let us see this practically. From the last example, we have seen that the result of the wc command on a file or standard in is displayed at the terminal window. What if we do not want to display this on the terminal? We want to store it in a file so that the information can be later used. By default, wc writes its output to the standard out. The standard out is by default connected to the terminal window. Hence we see the output in the terminal window. But if we can redirect the standard out to a file, then the output from the wc command will be written to that file. Say we write wc space test1.txt right angle bracket wc underscore results.txt. Press enter. Now to see whether this has actually happened, we can display the contents of wc underscore results.txt by the cat command. Yes, it has. Suppose we have another file test2 in the same directory. Now we again execute the command with test2 file. We type wc space test2.txt right angle bracket wc underscore results.txt. So the contents of the file wc underscore results would be overwritten. Let's see this. Instead, if we write wc space test1.txt right angle bracket twice wc underscore results.txt, the new contents will not overwrite the already present contents of the file wc underscore results.txt. It will be appended. Let's see this too. Redirecting the standard error is done similarly. Only difference is that in this case we need to mention the file descriptor number of standard error before the right angle bracket or double right angle bracket sign. Like we know that there exists no file by the name AAA, write the following: wc space AAA. The shell will give the error no such file or directory. Now say we don't want error messages on screen, they can be redirected to some other file. For this, we may give the command wc space AAA space 2 right angle bracket errorlog.txt. Now the error will not show on the terminal, rather it will be written in the file errorlog.txt. We can see this by the command cat space errorlog.txt. Now suppose that I make some other error by running the command cat space bbb space 2 right angle bracket errorlog.txt. The previous error would be overwritten and the new error will show. See cat space errorlog.txt. But what if we want to list all errors? Simple. We would run the command wc space AAA space 2 right angle bracket twice errorlog.txt. We'll check this using the cat command. We have seen how the three streams standard out, standard in, standard error are redirected and manipulated separately, but the real power of this concept can be gauged when we can manipulate the streams together, that is, connect the different streams. This process is called pipelining. Pipes are used to create chains of command. A pipe connects the output of one command to the input of the next command in the chain. It looks like command 1 vertical bar, command 2 hyphen option vertical bar, command 3 hyphen option 1 hyphen option 2 vertical bar, command 4. Say we want to know the total number of files and directories present in the current directory. What can we do? We know ls space -l will list all files and directories of the present directory. We can redirect the output to a file ls space -l right angle bracket files.txt. Run cat space files.txt. Now each line is the name of a file or directory. So if we measure the total lines in this file, we can use files.txt to serve our purpose. This we can do using the command wc space -l files.txt. Though this serves our purpose, there are a few problems. First, we need an intermediate file, here files.txt. If the first command produces a lot of data, it may unnecessarily eat away the disk memory. Also, if we want to change several commands, this method is slow. We can do it much easily using pipes like this. We write ls space -l vertical bar wc space -l, and we can get the same result with much more ease. The output from the ls command goes as input for the wc command. We can add even longer chains of command using pipes. One common use of pipes is for reading multi-page displays. Type cd space /user/bin. So we are now in bin directory. Now run ls -l. We cannot see the output properly, but if we use it joined with a pipe to more, we can. Press enter to scroll through the list. Press Q to come out of it. These were some of the commands that help us to work with files. There are many more commands. Moreover, each of the commands that we saw has many other options. I encourage you to see more about them using the man command. The best way of learning commands is to use them again and again. This brings me to the end of this tutorial. Spoken tutorials are a part of the Talk to a Teacher project supported by the National Mission on Education through ICT. More information on the same is available at the following link. This is Abhijit Sunil signing off. Thank you for joining.